Today's objective is I can explain how GitHub works and sign up for an account. Pretty easy lesson. Don't get overwhelmed because a website like this sure can be overwhelming. We're basically just getting an account, and I want you to, at the end, describe the process of Git and using a commit, okay? And your essential question of the day is, why are version control systems significant to a web designer? And the word version control is just what GitHub is. So we have a few Think Right shares, and then I want you to watch this intro video on GitHub, then create an account and explore on your own. We'll also use this website for hosting service. That means you can create your very own web page and send it to family or friends across the world. Anybody can access this web page you create because GitHub will be hosting these pages for us. And then eventually, what we're going to use GitHub for is to code together, so we can accomplish some pretty large projects together. What we haven't started in class yet is actually learning how to do that coding. So we haven't done very much HTML and zero CSS so far. In progress, you're learning more and more about elements and attributes, how to use these. And at this point, you should definitely be done with learning what tags are and how you use angle brackets to create tags in HTML. So Think Right Share says, summarize the GitHub website. Basically, GitHub utilizes a version control called Git, and this is for programmers are going to probably emphasize the fact that you're using a tool called Git, and that GitHub is just simply a website you can go to for that. A lot of people who are using the command line to work, they're able to do the same things you can do on GitHub from their command line. So the big thing about Git is it tracks changes made in computer files. So Git was created by Linus Torvalds in 2005 for development of the Linux kernel. And that's interesting, 2005. So this is relatively new technology we're working with. That's a great thing about this class, is we're not doing much ancient history here. This is some new stuff for everybody. And then if you don't know what the Linux kernel means, okay, just forget about the word kernel right now and know that Linux is a very popular operating system. That's definitely something you'll want to be familiar with if you want to take programming or the tech jobs or take a tech job in the future, okay? So as of April 2017, GitHub reports having almost 20 million users and 57 million repositories. Repository being basically the largest file you can have. When you create a website, a web page, you will start with a repository. And that's the largest file. Okay, so that's the entire project. If you were a game developer, the repository could be everything that the game has: the images, the sound, the physics. All that information is within that one repository. And these facts, the 20 million users, 57 million repositories, these facts make GitHub the largest host of source code in the entire world. What happens if no change is made to a file? So far I've explained to you that GitHub is a version control system. You can change things and it'll track it for you. That's what a version control system does. It says every time you commit or save the state of your project in Git, it basically takes a picture of what all your files look like at that moment and stores a reference to that snapshot. So it stores that reference. It stores the changes you've made at that moment. Now, to be efficient, if files haven't changed, Git doesn't store the file again, so you're not going to see a redundancy there. Just a link to the previous identical file it has already stored. So Git thinks about its data more like a stream of snapshots. And that is a great way to look at things in technology as snapshots. You're going to learn what a disk image is, and things like that. Okay, so that's later. Let's look at this stream that I was just talking about, a stream of snapshots. So let's say you have a version. Okay, let's go with the video game idea first. So you're making a game, and in file A you have the sounds, all the sounds that the game will have, the music, the sound effects. File B, let's say that's the images you're using, and then file C could be like the physics of the game. When you push forward, what does the movement look like? If you fall down a hole, what does that look like? So here's our 3 files for our basic game. Now we're all working together, right? A game such as Destiny that has like 3,000 people working like several years on creating it. So you have a lot of people working in these files. But let's make it seem like our game is, much smaller here. So file A, let's say they make a change to that. So now we have A1. File B, there was no changes at all, so that was just left alone. And then file C, somebody made a change and fixed some of the physics. Okay, so now C has changed too. So now we got version 2. When these changes were made, it went to the person in control of the versions. Okay, let's call that person Highlander for right now, just because of the concept there can only be one. So the Highlander accepted changes in A1 and accepted changes in C1. So now we have a new version for everybody to work on, everybody to look at. Version 3 starts. So B is still being left alone, haven't made any changes. And now no changes to A1. But C has some sort of change. So now we have a new version. People were working on this file, and it goes on to the next version, okay? And so now we got A2, there's a change there. B1, change, no change, save. And here's our final version. There's another change in file B, it looks like, and C. Okay, so now we're done. This is a great way to keep people from changing the same thing over and over and over and over. So the way we check to make sure there's no redundancy in this, every little change has its own what's called checksum. And so a checksum, it says here, is a number which is calculated by running several other numbers through mathematical operation, okay, for a check, right? And it allows someone to send these numbers to someone else, and the receiver can determine with a high degree of certainty whether those numbers have been changed in transit. And in some checksum algorithms, it can allow the receiver to reconstruct one number of the group if it is lost. So, I mean, this is just the concept of a checksum. Every change has a checksum. A picture is worth 1,000 words here. So let's say these numbers are sent to somebody. The checksum value could be 7. So every time you get a package from this person, the package numbers, they need to add up to 7. So you can simply do that, 1 plus 2 plus 3 plus 1. Now we know that these are the right numbers that were in transit, right? If this number, let's say we thought this was a 0 for some reason, and we're going through adding these up. If this is 0, we know it's wrong. So one of these is needing to be increased by 1, and we could figure that out. Okay, so here's a whole nother set of numbers, but they still add up to 7. So the package is good. We use checksums in barcodes. So when you're at the grocery store shopping and then scanning this, that corresponds with a number for a product for a price, okay? And the great thing about a checksum is if just one of these numbers is off, the computer can figure that out. So let's say you're buying frozen vegetables and there's a little piece of ice on this number, the computer can still figure out what the product is. And checksums work in QR codes as well. So here's your challenge if you want to go and really figure out how the checksums work in these two examples. Show it to me tomorrow. Make a video, post about it for some extra credit. Just explain how QR codes and barcodes are examples of checksums. SHA1 is the way that GitHub checksums for every save, right? It's a 40 character string composed of hexadecimal characters, that's 0 through 9 and A through F, and is calculated based on the contents of a file or directory structure in Git. So a SHA1 hash looks something like this. That's really complicated and hard to read, right? Well, seeing how we're not talking about frozen vegetables, we're talking about small changes to gigantic files, huge files. GitHub has chosen to use this 40 character string, and it's not decimal, it's hexadecimal. So you have 0 through F as an option for each one of these. So that's the logic behind using SHA-1. Now, your think right share on this. What role does SHA-1 play in GitHub? What's it used for? Okay, so here's another visual to kind of understand what I'm throwing at you here. If you can get this part, you're going to be really good for the day, okay? So the Highlander, the person in control, has their repository in the working directory, okay? So then just some average Joe can go in there, grab a file, so fix something here, and then commit it, aka save it. And now it goes back to the Highlander. They are checking that save, they're checking the change, and if they like it, they'll accept it. They'll accept the pull request, it's called, and then it goes back into the staging area, and then people can change it again. It goes through the same process, okay? The Git directory is where Git stores the metadata and object database for your project. This is the most important part of Git and is what is copied when you clone a repository for another computer. So that's another great thing about GitHub. If you like a project, if you like a game, if you like a website that you can find on GitHub, you can do what's called cloning it, make an entire copy of the whole repository, lots of files usually, so you can clone it into your own account and then make your own changes. That's where modifications can come from. You know, in the game Minecraft, they're very popular for the mods they do. That's just a person cloning the Minecraft game and then going into the files and changing whatever it is that they're interested in changing. Okay, this guy does a much better job than I at explaining what I just explained. He's using the website itself and pointing at things. At this point, I want everyone to go to their computer and create your own account. Kind of poke around the website itself. So sign up for an account. Use your either your first or last name somewhere in your name in your username, please, so I know that it's you and I can start following you on here so I can see your work. Okay, and then you can just explore on your own for a little bit. And then when you're ready, here's your DOL. Today I learned. Okay, question number 1, what is GitHub? How does this website basically work? And number 2, why are version control systems significant to a web designer?